One of the things that we want to do with equilibrium is understand that every reaction can be looked at like an equilibrium. Some reactions have a really huge equilibrium constant. And because it's so large, we just essentially say it goes to completion, and some don't. And so we consider those to be equilibriums. One of the things that we can consider to be an equilibrium is autoionization of water. And it's this idea that if I take water itself and I have it in a collection of water itself, then it breaks up into H plus and OH minus. And this process has its own equilibrium constant, Kw. And so it's trying to get you to start to see that the equilibrium constant Kw is related to this idea that pH plus pOH equals a constant 14, right? And so where's this 14? Look, here it is right there. It's just the difference between having that expressed as a log or not. And so when we say that the equilibrium constant for Kw is equal to 1.0 times 10 to the negative 14, we mean the product of the OH concentration and the H plus concentration is equal to that value. Now, from our equilibrium concepts, we know that the stoichiometric relationship between H plus and OH as compared to water is 1-to-1. So that means the concentration of H plus and OH must be the same. And so we can say that X is the concentration of both of those. And so X squared equals 1.0 times 10 to the negative 14. And with that understanding, we can take the square root of both sides and we get X equals 1.0 times 10 to the negative 7. And so that's going to be true for both the concentration of OH minus, and it's going to be true for the concentration of H plus. And this is what the problem was asking you to solve. And that means we're done. Okay.